The final chapter of designing data-intensive applications takes an unexpected turn. After 500 pages of data structures and algorithms and distributed systems theory, Kleppmann asks the question most technical books never ask: what are we actually doing to people with these systems? Predictive analytics, building models that predict future behavior, has become ubiquitous. Credit scoring predicts whether someone will repay a loan. Recidivism prediction tools like Compass predict whether someone released from prison will reoffend. Medical diagnosis systems predict whether a tumor is malignant. Hiring algorithms predict whether a candidate will succeed. These models affect real people's lives in immediate and profound ways. A low credit score denies someone a mortgage. A high recidivism score keeps someone incarcerated. The decisions are made at scale. Millions of people run through the same algorithm and often without meaningful human review of individual cases. Here's the problem Kleppmann identifies. These models are trained on historical data that reflects historical decisions which were made by humans who had biases. A model predicting loan default, trained on past loan decisions made by loan officers who discriminated against black applicants, will learn to discriminate against black applicants. The model doesn't see race explicitly, it sees zip codes, employment history, and other variables that are correlated with race due to historical segregation and discrimination. The bias is laundered through the model's math. Worse, feedback loops amplify the problem. Predictive policing models predict which neighborhoods will have crime. Police patrol those neighborhoods more. More crime is detected in those neighborhoods. The model is updated with this data. The prediction becomes even stronger. The model has confirmed a pattern it helped create. The book quotes a pointed example: if a system denies job applications from people who live in certain postal codes, it may be encoding historical patterns of housing discrimination. The algorithm doesn't intend discrimination. It doesn't know what discrimination is. It simply found a predictive signal in data that was shaped by discrimination. Intent is irrelevant. The effect is real. Bruce Schneier, one of the most respected voices in computer security, has a phrase that captures something important about the modern web: surveillance is the business model of the internet. Almost every major free internet service, Google Search, Gmail, Facebook, Instagram, Twitter, YouTube, is free to users because users are not the customer. Users are the product. Their data, what they search for, what they click on, what they post, who they talk to, where they are when they use their phone, is collected, aggregated, analyzed, and sold to advertisers. The more data collected, the more accurate the targeting, the more money the advertising produces. This creates a fundamental misalignment of incentives. The service is optimized to maximize data collection and user engagement, not user well-being. Facebook's own internal research, revealed in 2021, found that Instagram was harmful to a significant fraction of teenage girls' mental health. The company knew. It continued optimizing for engagement. The data collected for advertising doesn't stay in advertising. It flows to data brokers who aggregate it across sources. It can be subpoenaed by law enforcement. It can be breached. Location data from period tracking apps, once collected, can be used to prosecute people for seeking abortions. Location data sold by a Catholic news outlet in 2021 revealed attendance at gay bars and identified a priest by name. Data collected for one purpose was used for another in ways users never anticipated. The GDPR, the European Union's General Data Protection Regulation, which took effect in 2018, codifies some limits: the right to erasure, the right to be forgotten, the right to data portability, and the principle of privacy by design. These are partial constraints on an otherwise unlimited surveillance architecture. The engineering question is whether the systems we build should collect all data that can be collected, or only data that should be collected. That question requires a values judgment that isn't answered by any algorithm. Kleppmann closes the book with a challenge that feels unusual in a technical text, but which he has been building toward for 12 chapters. Data systems are not neutral. Every design choice encodes values. The choice to collect data encodes the value that collection is acceptable. The choice to retain data forever encodes the value that future use justifies present collection. The choice to build a recommendation system that maximizes engagement encodes the value that engagement is what users should want. The choice to share data with law enforcement without a warrant encodes a view of the relationship between individuals, companies, and state power. Engineers who build these systems often think of themselves as neutral technicians implementing specifications. Kleppmann rejects this framing. He argues that engineers have agency, and therefore responsibility. The specifications are not handed down from on high. They are chosen. The business model is not a force of nature. It is a design decision. The book cites the concept of a duty of care, a legal doctrine in which professionals who provide services to others are required to act with the competence and care that a member of the profession would consider appropriate. Doctors have a duty of care to their patients. Lawyers have a duty of care to their clients. Engineers who build systems affecting millions of people arguably have a similar duty. Practical steps: consider the data minimization principle, collect only what you need. Consider retention limits, delete data when its purpose is served. Build in transparency, tell users what is collected and why. Build in access controls, not everyone internally should see everything. Consider conducting algorithmic impact assessments before deploying systems that affect people's lives. This is where the book ends, not with a new algorithm or a new architecture, but with a question: what are you building, for whom, and at whose expense? The answer to that question is the most important design decision any engineer makes.